Well, folks, thank you all very much for your patience there with our technical issues. But regardless, my name is Mark Megarry, and this is Hackers with Radios, Security and the Physical Layer. So today we'll do a bit of an introduction and then look at threat modeling for radio hackers, and that'll include eavesdropping, replay attacks, and relay attacks. And then we'll move on to a bit of attack mitigations and wrap up. So a bit more about myself. I'm a PhD student with Queen's University Belfast's Centre for Secure Information Technologies, and my project is focused on telecom security. Also, I am contractually obligated to promote the RF Hacking Village outside, so go check it out when we're done here. Okay, so this is a talk about hacking and radio hacking, so please don't break any relevant cybercrime laws. And as well as that, because we're dealing with the radio spectrum, please respect the legislation put in place in Ireland by ComReg. They regulate the spectrum here, and will probably fine you if you transmit on some band you shouldn't. So, radios. They're everywhere, but they don't all look like this. In fact, I'm willing to bet most people in this room have a number of radios on them right now. I mean, for me, I've got my phone on me. This has a Wi-Fi interface, it has a Bluetooth interface, cellular, and it has a GPS receiver. These are all technically radio interfaces. I'll not show you these, but in my wallet I've got my contactless payment cards and my employee ID. I'm sure most people in this room use wireless keyboards and mice pretty often. And in fact, here's a question. If you use a wireless keyboard pretty regularly, are you sure that the message that gets sent when you press a key, are you sure that that's encrypted and that someone in the other room can't read what you're saying? If you haven't thought about it, it's worthwhile. And we'll be talking a bit more about these later, but car keys. So they can be split into remote keyless entry, and that's the idea where, if I can find the car key, that's the idea where you press a button on your key, that sends out a signal to your car, and your car opens. But there's also passive keyless entry. That's the idea where you have your key in your pocket, you walk up to your car, you pull on the handle, and it just opens. Additionally, your keys have a transponder built in. Your car's immobilizer, when your car is starting, looks for this transponder. If it's there, the immobilizer will disable and the car will be able to go. If it's not there, then you're stuck. Also, if you're into your smart home and automation stuff, just because your smart lights don't run on Wi-Fi doesn't mean you can't talk to them with the right USB interface. You can communicate with them. So, one of the sort of key issues with wireless communications is that, let me just silence my phone real quick. One of the key issues with wireless communications is we tend to think about comm links in the system diagrams like this, like it's a straight line. And yeah, you can transmit radio power in a fairly concentrated focused beam using things like beamforming or directional antennas. But really for things that I have in my pocket right now, generally, when I press a button on my key fob, it's going to radiate in all directions. So in the first instance, an attacker might have to physically get between you and the device you're talking to. But in the sort of more common situation where you're transmitting in all directions, they can be anywhere, even in the next room. So what can these attackers do? Well, I like the Dolev-Yao adversary model. This essentially says that the channel itself is the attacker. So under this model, attackers can eavesdrop on messages. They can transmit new messages sent on the They can block messages through jamming, or they can modify messages in flight. So let's look at an example of eavesdropping. So I've gotten a bit into amateur radio recently, and here's a setup where, let's say, Bob is trying to talk to Alice through a repeater. Now, amateur radio voice communications generally aren't encrypted. So we can place a device anywhere within range of Bob, and I used what's called a software-defined radio for this. And whenever I recorded myself, I'm really hoping that the audio plays here. This is what we heard. Okay, the audio's not playing. Well, take my word for it. If you put a software-defined radio and you set it up right, near Bob, you can listen into exactly what he's saying. So let's move on swiftly to replay attacks. This is one of the oldest tricks in the book, but we have this scenario where we have Bob trying to talk to his wireless device with a key fob. So I'm going to use the example of a garage door opener. We know from earlier that when Bob presses the open button on his key fob, he's not just transmitting to the device, he's transmitting all around him, and that means that an attacker can listen into this. So an attacker can record the message Bob sends, wait until Bob leaves, and then just replay the message that says open garage, and the garage will open. Okay, what hardware might an attacker use to carry out these attacks? Well, one of my sort of favorites in terms of the flexibility is the Hacker F1. This is what's called a software-defined radio. Now, what a software-defined radio is a device which, when it receives a signal, it creates samples of the waveform and sends those samples onto your PC, so your software can put together the original waveform. So you can do more advanced analysis with this. The Hacker F1, it has a broad frequency range. It's a little pricey for a bit of hobby kit, but it can also transmit, which is pretty major. But on the cheaper side of software-defined radios, you have what's called what I'm going to be calling the RTL SDR. These are cheaper devices, generally about £40, €40 or less. They can only receive, and they have a limited frequency range, but you can still listen in to things like car keys, things on 433 megahertz with them. So, if you're curious, this is something that's worth picking up. Now, it wouldn't be a radio hacking talk in 2025 without mentioning the Flipper Zero, of course. So, unlike the software-defined radios I've been talking about, the Flipper Zero, it doesn't give you samples of the original waveform. It can just give you data out because it's based on the Texas Instruments CC1101 module. This will receive and decode signals using certain modulation schemes, and modulation is how we encode data onto a radio wave, but don't worry about that so much for today. But the benefit of the Flipper Zero is just, it's versatile. It's a Swiss Army knife. It does RFID, it'll do Bluetooth and things like that. So, it's a nice tool to have. But, I wasn't too pleased with the price range for it, so I thought, well, it uses the TICC1101 module. I can make my own, right? So this is my arts and crafts project. If it worked, it would cost less than £30, but as you can tell from that, it to this day does not work. So maybe one day. And I need to give one honorable mention to the best hacking device of 2007. Folks, this is the Girltech IM-Me, originally designed by Mattel as an instant messaging toy for kids. It features a Texas Instruments CC1110 sub-1 GHz microcontroller, and people found pretty quickly that you can upload custom firmware onto this device. People have used Sammy Kamkar's Open Sesame to brute force garage door openers with this pink device. It's been shown to be able to jam P25 secure radios. So for something that sold for about $65 back in the day, that's pretty good. But let's get on to an example of a replay attack. So I was at Farsight Labs, it's a hackerspace in Belfast, and I came across this projector screen loader. So you press up on the remote, it goes up, you press down, it goes down, pretty simple. So I borrowed a friend's Hacker F1, and I played the role of the attacker. I used a bit of software called Universal Radio Hacker to listen into the signal I received, and it looked something like this. And you might say, Mark, that's not data, that's a squiggle. But this is what's called amplitude shift keying, or on-off keying. So when it's on, it's a 1, when it's off, it's a 0. It's dead simple, but you see it often. I mean, car keys quite often use this, so it's a popular modulation scheme. But I didn't have to do any complex analysis of this. All I had to do was press replay, and then the projector screen rolled up. So that's great. We've used over £200 worth of kit to defeat a £20 remote controller that had no security guarantees. So I thought, well, what's a reasonable next step? What's something with some some oomph to it, some security expectations, and then it hit me. My car. Well, thankfully my car didn't actually hit me, but the idea hit me to try and break into it. Now, if you try the same sort of replay attack on a car, you take your car key, you record the signal, and you replay it, you'll sort of be met with a deafening silence. The car's not going to unlock. And that's because car locking systems tend to use what's called rolling code. So in rolling code, your key has a counter variable, and your car has a counter variable. When you press a button on your key, it transmits a message to your car. That message contains an encoded version of this counter variable. I'll call it a hash for simplicity. It contains a hash of this counter, and it contains the action to be taken. So lock, unlock, open the boot, all that. When your car receives a message, it checks the hash of the counter that was sent, and it compares it to what it's expecting. So this means that if the key is out of date, if the key is sending an old counter value, then the car is going to ignore it. So you can't use the same counter twice. So does that mean that my car can't be unlocked by an attacker? Well, unfortunately, Sammy Camcar came up with an attack called roll jam, and these are two different bits of hardware that have been put together for roll jam. You'll see there are two radio modules on the top one. So one is for transmitting and receiving, and one is for jamming. So here's how the attack works, right? Bob presses unlock on his key, but the attacker is jamming the car's receiver. So the attacker hears the message that was sent by Bob, the car doesn't. Bob says, well, that didn't work, and does the very human thing of pressing unlock again. Okay, the attacker now has two messages, one older than the other, and the attacker just sends the older of the two messages, keeping the fresh one. So we can keep doing this in a loop where we have two messages in our buffer, and we send the older of the two messages until it's time for Bob to go to work or go to bed or something. We still have one message in our buffer that is valid and hasn't been used yet, and we can transmit that to unlock the car. So I really wanted to try out this attack for myself. Problem is, radio jamming is really illegal. So I thought, yeah, okay, I'll have to go back to the drawing board with this one. So I went for this relay attack. So here's the situation. We have Bob, who's far away from his car. There's an attacker next to him. And then there's an attacker next to his car. Bob is playing with his keys, or the attacker grabs the keys quickly and records the signal sent from them. And then that attacker sends the message to the attacker closest to the car. I show this being done over satellite comms, but it's probably going to be a text message or something. Attacker 2 just sends the unlock message that the car hasn't heard yet, and the car unlocks. So here's a quick demo of how that might look. So I'm at my desk, far away from my car, with the Hacker F1. I press unlock, I record that, and then I walk some long distance to my car where it was out of range. And then we take this message that the car hasn't heard before, and we replay it. And the car unlocks. So yeah, that is worrying. My car has been unlocked without the key being present, but is this attack practical? Well, I have to wonder, if I see a car on the side of the road, it's got a laptop or a nice watch or something that I really want, am I going to run home and buy £200 worth of radio equipment off of Amazon, wait for it to arrive, stalk the owner of the car, carry out this convoluted attack? Well, no, I'm probably going to do a much cheaper attack, pick up the nearest brick and put it through the window. So for opportunistic theft, I think this isn't so practical. But in terms of getting you in the car, yeah, I could get someone in the car maybe without the knowledge of the owner, so they could then try and maybe start the car, steal it. But its use is, it's maybe not as bad. It's not as practical as it might first seem. Now, an attack that's a bit more practical is an attack on passive keyless entry. So, the user has his key in his pocket, and he walks up to the car and pulls on the door handle. The car sends out a challenge to the key. If the key is present and valid, it will then calculate and send a response. And we have this fatal assumption at the bottom, that because the transmit power of both parties is limited, the distance that this can happen over is quite short. But this isn't always true. So you might have seen a video of this attack happening on YouTube or something, but we have what's called the two-thief attack, where picture this scenario. It's at night, the owner of the car is in bed, their key is in their house, and we have an attacker with an antenna next to the house, who's just trying to find the signal from the key. We have an attacker next to the car with an antenna, who then pulls on the door handle. The attacker receives the challenge from the car, sends that over to the other attacker through some higher power method than the key has. So the attacker sends this challenge over a very long distance. Then the attacker next to the house forwards that onto the key. The key calculates the response, sends that back to the attacker who's close by. He forwards that onto the attacker next to the car, who forwards the message onto the car, and the car unlocks. So we've essentially destroyed the assumption that the distance this can be done over is very short. So then the attacker next to the car gets in, they can repeat this attack, and attacker 1 is away with the car. So let's talk a bit about mitigation. So here's some advice from the PSNI up north. So they say, when at home, keep your car key well away from the car, fair enough. Put your car keys in a signal blocking pouch. Reprogram your keys if you buy a second-hand car, and turn off wireless signals on your fob when it's not being used. Now, I don't disagree that this is decent advice, but I have to wonder, what if this was applied to the newest iPhone? Imagine if you got the newest iPhone home, you open it up, you unbox it, and there's a big leaflet in it that says, warning, when you're not using this, you need to keep it in a Faraday bag, or all your bank details are going to be public knowledge. And you've got to turn off Wi-Fi when you're not using it because we can't guarantee it's secure. So I just think it's odd that the onus here is on the user rather than the manufacturer. So some proposed solutions then from researchers. So we have the solution of using encoded timestamps. So we know that radio signals propagate at the speed of light in a vacuum. So if your car receives a signal from a key that was sent 2 minutes ago, that's some distance away. That's a bit odd. So you can work out what's the maximum freshness of a message you should accept. Then researchers have also been looking at using machine learning techniques to fingerprint signals. So did this come from a legitimate key, or did it come from some other device? You can maybe look at the noise associated with the devices to work out if it's a legitimate key or not. And then we have, we could look at using physical metrics like the received signal strength, round trip time, GPS coordinates. But ultimately, an issue is car key fobs, they're not high-cost devices, right? Manufacturers really want to try and keep the cost down because you don't want to buy a £10,000 key fob at the end of the day. So, what are the takeaways? Well, when you broadcast a message from a wireless device, you can't generally control who's going to receive it, only who understands it. Security in hardware is a bit of a balancing act because you really want a secure key, but you also want a cheap key, right? And I just always like to ask the question, do we need to have higher expectations regarding wireless and hardware security testing? Are we doing enough? I like having that conversation. And if you're an interested beginner in this stuff, I'd recommend checking out the RSGB in the UK, or their equivalent down south here. Now, other topics I want to bring up in the future. Wireless keyboards and mice. We talked about them a bit at the beginning. But there was a company called Bastille Networks who found that a number of pretty big name brands had products that weren't so secure, that maybe were leaking your key presses. So I'd want to play about with that a bit more myself and just see that with my own eyes. Additionally, I want to look a bit more at older telecoms networks. So old school hacking involved what's called phone phreaking or blue boxing. So very old telecoms networks used audio for control messages. So people made these tone generators that they used to explore parts of the phone network they shouldn't. And then I want to sort of tie that into a talk about more modern 5G RAN and core network security. So keep an eye on that. Okay. Well, thank you very much, and thank you to Grant for lending me his Hacker F1, my dad for filming me breaking into my car, Farsight Labs for letting me play with their projector screen, and Sammy Camcar for inspiring this talk. And we'll be taking any questions.
Although with the bridge, that with the flip a zero, there's a risk that when you copy a card, that it breaks the card. That's one of the side effects of not being properly.
Yes, so your car has a sort of tolerance, so your key can be a couple of presses ahead of the car, but I know from walking around the car park that didn't actually have my car on it and clicking my car key a bunch of times, if you click it, I don't have a solid number, but if you click it too many times, you'll not break it, but you'll have to resynchronize them. So for me, I think that just involved using the mechanical key and then just starting the engine with the key nearby. But that's definitely, it can be an annoyance.
So was it a security feature? It's just a byproduct of the design and copying the codes?
Yeah, so yeah, your key can be a couple presses ahead of your car, but there will be situations, if you play about with the stuff, you will need to resynchronize those two together. Okay, so if that's us going once, going twice. Okay, well, thank you, everyone.